Alright, so this last section in chapter 1 is about absolute value equations and inequalities. Absolute value equations, things get a little bit tricky because, because absolute value. So we're going to mess around with those a little bit. And so as usual, we're going to start out, We're going to start out the section with a little problem for you guys to do on your own, the old getting ready. I think this one you're going to be able to do very quickly. It says you're riding in an elevator and decide to find out how far it travels in 10 minutes because you're that guy. Okay? I know you're out there. Seth, you're in the elevator and you're like looking at that one, I know what to figure out, because the brain's always, future engineer. You start on the 3rd floor and record each trip in the table, so you're just like hanging out in the elevator, people are getting in, getting off, you're going up and down, they're looking at you funny. But you're doing math, so it's all good. How far did the elevator travel in all? So first you go up 8 floors, then you go down 6, then you go up 9, then you go down 3, and then you go up 7. So this should be a very, very quick problem. Work on this while I come around and pick up your worksheets from yesterday. You have those all in a pile. That would be super duper awesome. Sam, what's the answer? 396 feet. How did you get that?
I did 8 plus 6 plus 9.
Time out. Why did you do plus 6? It's clearly a negative 6.
Because it went down 6.
Right, so it should be minus, right?
No.
No?
No.
Absolute figure how much it went all
How far did the elevator
How far did it go? So it doesn't matter whether it goes up or whether it goes down, it's still a distance. Okay, I apologize for interrupting. Continue.
8 plus 6 plus 9 3 plus 7 equals 33, and then you multiply that by 12 because it's 12 feet per floor, and then you get 396.
There you go, spontaneous applause. Okay, yes, that's absolutely correct. So then they end up traveling a total of 396 feet. And the whole idea here is, the clue was that we're talking about absolute value. And absolute value does what?
It stays. It doesn't matter if it's
It doesn't matter if it's negative or positive, it always makes it positive, okay? And so the easy way to think about absolute value is considered to be a measure of distance, okay? And that's what Sam was saying. Plus 8, they've gone 8 floors, minus 6, they've still gone 6 floors. We never talk about distances in terms of being negative, okay? All right, so if you haven't seen this for a while, this is a little refresher. It's the funny little lines around it. The absolute value of 4 is 4. The absolute value of negative 4 is also 4. And then what we're going to do a lot is we're going to end up breaking this up into 2 different equations, depending on whether x is positive or negative. But we'll talk more about that in a little while, okay? And so if you wanted to graph something like this on a number line, this is why the absolute value of negative 5 and 5 are both 5, because like I said, we're talking about it in terms of distance, and both of these numbers are 5 units from 0, okay? So the absolute value of those is 5. Okay, so what's the solution of 2x minus 5? Absolute value of 2x minus 5 equals 1. So this is where things get just a little bit dicey, okay? What could the stuff inside the absolute values equal in order to make this equation true? Bless you, I think, or I don't know what. Okay. What could this equal? What could 2x minus 1 equal and have the absolute value of that end up being 5? Yes?
3 and negative 3.
Whoa, you're way ahead, you're solving for x. What could the 2x, what could this stuff in here equal so that when I take the absolute value of it, I get 5 as an answer? Who said? 5, okay? Because the absolute value of 5 is 5, all right? But since it's absolute value, there's a bonus equation in here. What else could 2x minus 1 equal so that if I took the absolute value of it, I would still get the answer 5? Yes, negative 5. So when you see an absolute value equation, you get to solve not just one, but two equations at the same time. Yes, it is two equations for the price of one. So that's totally awesome. All right. So Sam was a little bit ahead of the game, and he thought that he came up with the solution. And you said what?
3 and negative 3.
Okay. How'd you get the 3?
From adding 1.
Okay, so you added 1 and then divided and got 3. How did you get negative 3?
Well, if we did that.
He's shaking you off. Talk to me, Garrett.
That'd be wrong then?
Yeah,
Maybe equal
you have to
negative
add.
7.
Right, because if I put in a negative 3 right here, 2 times negative 3 is negative 6, minus 1 is negative 7, and the absolute value of negative 7 is not 5, okay? So what Sam is dealing with is a situation where it is only the x inside the absolute value symbols. Then yes, you're absolutely right, your two answers are 5, and also it's opposite, okay? But when there's more stuff in there, it's not quite as easy, and so that's why we have to write out this separate equation. How can I solve this equation over here? Add 1. Just like we did before, but this time instead of getting 2x equals 6, since it's negative 5 plus 1, it's 2x equals negative 4, so my other answer is negative 2, okay? And you can check that by plugging it in. Negative 2 times 2 is negative 4, minus 1 is negative 5, and the absolute value of that is, in fact, 5. Okay, so then if we graph the solution, then I get 3 and negative 2, and a dot at each one. All right? Nifty? All right, I believe it's your turn now. Absolute value of 3x plus 2 is equal to 4. Figure out what two values of x will work to make that true. And I will give you a little hint. We are in advanced algebra, so sometimes we get answers that are fractions or decimals, and that is okay. Everybody eventually got to the right place in the end. You get two answers. One is when this equals 4, the other one equals negative 4, and those come out to be 2/3 and negative 2, right? Okay. All right, so let's keep going. Now let's, of course, make things a little bit more complicated because, again, this is advanced algebra. So now instead of just the absolute value of something equals a number, we've got all kinds of other numbers in there too. So your problem-solving strategy here is when you come across absolute value equations like this, the first thing you need to do is get the absolute value stuff all by itself, all right? In other words, the first thing I'm going to do is I'm going to get rid of this negative 1, and I'm going to get rid of this 3. And then I'm going to do the trick that we just did. So how can I get rid of this negative 1?
By adding it
Add 1 to both sides. So if I add 1 here and I add 1 here, those cancel, then I get 3 times the absolute value of x plus 2 equals 9. How do I get, then I divide both sides by 3, good. And then that sets me up, like I said, in the same situation that we were in the last problem. I now can write two equations based on this. What's the first equation that I can write? X plus 2 equals positive 3, and then I also need to solve x plus 2 equals negative 3, all right? The good part of this is I know it's a pain to have two separate equations, but the steps for solving them is always going to be the same. I'm going to subtract 2 from both sides on this one, and I'm going to subtract 2 on both sides from this one. So those cancel, it gives me x equals 1, and over here those cancel, it gives me x equals negative 5, okay? Any questions about that?
Yeah, can you treat the 3 like a, not the 3, but the absolute things, the minus, like parentheses?
Yes, basically they're like parentheses. Yeah. Oh, no, you can't distribute them. No, I see what you're saying. No, you need to just get them by themselves first. Yes.
So you're just dividing the 3 away from it.
Yep, yep. Just trying to get the absolute value thing all by itself first, and then do what we
Okay,
just
since it's not parentheses.
right. No, you don't. That's what anyone was asking. All right. So why don't you try this one on your own? Okay. Work through that one. Remember, you're going to get probably 2 answers to start with. Okay, so we had a few stumbles there, so I'm glad we had this talk, okay? The there's a temptation by a handful of you guys to say, all right, this means I have to solve two equations. One of them is 2 times the absolute value of x plus 9 plus 3 equals 7, and the other one is 2 times the absolute value of x plus 9 plus 3 equals negative 7. That is incorrect, okay? But I'm glad that I saw that out there a little bit so we could address this problem. We do not do the plus minus thing until we get the absolute value stuff all by itself, okay? So my first job is to subtract 3, so those cancel. 2 absolute value of x plus 9 equals 4, then divide by 2. So absolute value of x plus 9 equals 2. And now, since I have this absolute value thing all by itself, that's where I'm going to write two separate equations. One of them x plus 9 equals 2, and one of them x plus 9 equals negative 2. Does that make sense? Okay, so you don't flip and do two things until you get the absolute value stuff all by itself. Okay, then this one comes out to be negative 7, and this one comes out to be negative 11. So those are my two answers, okay? Any questions about this?
Don't rip it.
Don't rip it. Yeah, listen to it. Okay, every once in a while, we'll be going about our business here, doing some algebra. We'll get two answers like this, and for some crazy reason, one of them does not work, okay? And when that happens, that is called an extraneous solution, okay? And so when it says check for extraneous solutions, that's a clue that somewhere along the line we did some math that introduced an answer that isn't actually right, okay? So let's take a look at an example of what that is all about. So now things are getting even more complex. Now I have the absolute value of 3x plus 2 equals 4x plus 5. So this is exciting because now I have variables on both sides, okay? What do I do first to solve this?
Rewrite the equation.
Rewrite the equation. I already have this as only the absolute value, right? So there's no setup that I'm going to do first, so I can go right into writing my two equations. One of them is going to be 3x plus 2 equals 4x plus 5. What's my other equation?
Negative 4x.
Negative 4x minus 5. I've got to switch everybody around. So my other one is 3x plus 2 equals negative 4x minus 5. So this is a little bit trickier even still. Okay? How do I solve this? Subtract 3x from both sides. I always like to have my variables be positive. So I'm going to take that over to this side. And then subtract 5. And so one of my answers appears to be that x could equal negative 3. Okay? Over here I do the exact same thing, but now since this is negative, what am I going to do to start this instead? I'm going to add 4x so I can keep my x's positive. So 7x plus 2 equals negative 5. Okay, now what?
Minus 2.
Subtract 2 from both sides.
Negative 7.
So 7x equals negative 7, which means x equals negative 1. All right? But they gave us this little clue here. Check for extraneous solutions. So that's sort of a sign that one of these is not going to work. And so to figure out which one, I have to plug them both back into the original equation and make sure that they both work. So if I plug negative 3 in here for x, what's 3 times negative 3? Negative 9 plus 2 is negative 7, and then the absolute value of negative 7 is 7. So for that one I get 7 on that side. And then watch what happens here. When I plug in negative 3 there, 4 times negative 3 is negative 12 plus 5 is negative 7. So this one is a fail. Okay? That is an extraneous solution. It looks like it's going to work, but it's actually not. Okay? Let's check this one right here. If I put negative 1 into here, 3 times negative 1 is negative 3 plus 2 makes negative 1, and the absolute value of negative 1 is 1. Then if I plug negative 1 in over here, 4 times negative 1 is negative 4 plus 5 is also 1, so that one works, okay? So our only answer that actually works for this problem is x equals -1, okay? All right, so you give this a try of your own.
I got that far.
Okay, first part is there on the board. So you can check your work if you want. Remember, we get 2 equations here right off the bat because the absolute value is already all by itself. So one of them is 5x minus 2 equals 7x plus 14. And if you solve that, you should get x equals -8. Okay? And then the other equation is 5x minus 2 equals -7x minus 14. And if you solve that, you get x equals -1. Okay? Raise your hand and tell me if you figured it out. Which one of these does not work? Which one of these is a liar? Blake. -1. -1, because if I plug -1 into here, 5 times -1 is -5, minus 2 is -7, and the absolute value of that is 7. And then if I plug -1 into here, there's 7. Yeah, okay, so actually that one works. Okay. So which one does not work? -8. Because if I plug -8 into here, I get -42, and the absolute value of that is +42. And if I plug -8 into here, then I'm going to get -42, and those two things aren't equal. What's the fast way? Anybody see the fast way of checking this? Yes.
If there's a 1, it's usually right.
If there's a 1, it's usually
That's
right.
the answer.
Okay. What's another fast way of checking this? Where you don't have to plug them into both sides. You can just plug it into one of them. Can this side of the equation ever be negative? No. So if you take one of these answers and plug it into the right side and you get a negative answer, then you know that's not going to work because there's no way you're ever going to get a negative on this side, okay? So if you want to save yourself a little bit of time, instead of plugging them into both, just plug them into this, and if that's negative, then that is totally out, all right? Okay, there's more in the section that's on inequalities, but I think from walking around and looking at your work, you guys need some practice on this before we move on. So I'm going to go ahead and give you your assignment right now. So that means we will not have a quiz tomorrow. I don't know when we will not quiz tomorrow. Give me a dinner.